Okay, so the next thing we'll take a look at is routers. Routers are the most complex networking device we will consider in this course. Routers are used to connect two LANs together. So you have typically the routers in the lab have two interfaces, they're called. They're basically just NICs, actually, network interfaces. And so the term that we use for switches is ports. The switches that we use might have 48 ports, and each of those ports are just network interfaces. But for whatever reason, they call ports on switches, and you also have network interfaces on routers, but they're called interfaces. And usually there's just two of them. Two is the minimum. You can't have more. So some of the routers we'll look at in this lecture series, in these lectures, we'll have a lot of them will have two, some of them will have three. So a router just decides whether a packet or frame coming from one side should move on to the other side, and most of the time that's where it's going. So for example, if you have one computer in this LAN 1 connected to a switch sending out a broadcast frame, the switch will take it and send it out to all the ports. One of the ports being connected to the router, it will go to the router, but the router gets that frame, notices that the destination MAC address is all F's, and it'll say, I'm not going to propagate that. So it's not going to send it anywhere. It just drops that frame, because that's the whole idea of LANs and routers, is that switches will propagate or broadcast a broadcast frame. Routers will stop it. Main reason is that if you do propagate these, then the whole internet, the whole network will be like swamped with people broadcasting, asking for information about other computers and things like that. And that's not something you want to do. You want to maintain the broadcast pack frames, keep that within your collision or broadcast domain, which would be this LAN, everything connected to the switch, and stop it at the router. Routers is supposed to stop them. Okay, so once again, you have a LAN, you have another LAN, you can have multiple switches. If you send a broadcast frame on a machine that's connected to this switch will send it out. It'll be received by this switch, and this switch will also send it out on all the connections, but it'll stop here. Okay, and the main function of routers is to communicate, is to allow systems, stations on each of these LANs to communicate to each other, to computers on the other LAN. So routers are different from switches. Routers connect local area networks together. Switches connect, we'll say, computers or individual stations, but remember that a switch can also be connected to another switch. Routers use IP addresses, whereas switches use MAC addresses or physical addresses. Routers work with packets, switches work with frames. Routers will stop broadcast frames. Switches do propagate broadcast frames. Just like switches we saw have switching tables, routers use routing tables, and that's the next thing that we'll take a look at. So routers, what kinds of situations can you expect to see them? You may have a router connected to other routers. That's always possible. You may have a router that's connected to a switch, or maybe multiple switches. That's also possible, like we saw in a couple of slides ago. Or you may even have routers connected to a single computer. That's not so frequent, or any combination of this of all of these. So you may have a single router connected to another router, a switch, and then maybe another computer as well. Okay, so as you start adding computers to a local area network, you will probably notice that each machine, trying to figure out where all the other machines are, will send out broadcast traffic or broadcast frames. And so the more stations or computers you have on a local area network, the more likely it will be that there will be broadcast traffic. If it's too big, your whole network will be swamped with broadcast frames. And so it's a good idea to, if you have a network with a whole lot of stations, including servers connected with multiple switches, you can do this. But there's probably a better way to do things. And the better solution is to like divide up your networks into parts that will contain the broadcast traffic within these different, what they're called, segments. So, which is a word we'll use for other things too, but this this is called segmenting out a network. That is, since a router will stop broadcast traffic coming in, any broadcast traffic from here is not going to swamp these other LANs. It's going to get stopped at the router. Same thing with broadcast traffic here, here, and so if you have broadcast traffic in one segment of your network, that doesn't interfere with communications between other segments and makes each of the other things, at least makes it faster. Overall, you get better speed, better performance if you stop broadcast traffic. And so we say that routers segment a network. And so each router interface, in this case there are three of them, you can think of them as three NICs, but there's a lot of intelligence or smarts built into the router. And it knows that if there is a broadcast frame coming in, the routers will just not propagate it to the other interfaces. So it's one thing to keep in mind of one reason for using routers is to stop broadcast traffic from being propagated. So routers have switches, as we talked. I'm so sorry. Routers have tables, as we saw in switches. So switches have tables where you have port and MAC address pairs, so that you know when a switch gets a frame, it looks at the destination MAC address, consults its switching table, and figures out which port to send it out on. And routers have something similar. It's not exactly the same, but very similar in that you have IP addresses, and this is not a real IP address. This is just a sort of shortened IP address, just to make this diagram simple. So routers will have an IP address and an interface, very similar to the idea of switches with the MAC addresses and ports. Okay, so in this particular example, router, it has three interfaces: Ethernet, Ether A, Ether B, and Ether C. And so what the routing table has is the destination. So this says that if you have a packet that's destined for network 1.0, that message should go out on Ethernet A. And you look in here, and you see Ethernet A is connected to network 1.0. Same thing over here. If you have a packet that's going to destination 2.0, and remember this is just a sort of shortened, sort of fake IP address. If you have 2.0, and this is going to Ethernet B interface. So router gets something, let's say from 1.0 that's destined to 2.0. It says 2.0, I know where that is. I'll just have to send it out on interface Ethernet B. Sends it out and reaches its destination. Okay, and same thing with 3.0 is connected to interface ETH C. So now we have a slightly more complicated example where you have three routers, and so you might want to send from network 1 to network 3 or network 1 to 5. And notice that if you're sending out a frame, we'll look at more details of how this is done, but for now let's just say that 1 is trying to send to 3. It will have a packet with the destination IP address of some network in 3.0, and so the way this works is We'll talk more about this later, but it will put, if it figures out that the destination of the packet is outside this local area network, it will send that packet in a frame to the router. Okay, so we'll worry about the details later, but let's just say that the computer knows that it's going to send a packet to another LAN, and so it has to send it to the router. So let's just say that happens. Router will take a look at the frame. It'll say, yeah, this frame is destined for me. It has my destination MAC address. It'll open up the frame, look inside, take a look at the packet. It has a packet. It'll see a packet with the destination 3.0. It'll consult its routing table, and for 3.0, the interface that it's going to send it out on is WAN A. Okay, so each router only knows about the interfaces that it has. It doesn't know about really know about what interfaces other routers have. So these unfortunately are named the same thing, but they're two different things. This is the WAN A port for router 1, WAN A port for router 2, WAN B port for router 2, Ethernet A port for router 2. So don't be thrown off by this. These are separate interfaces. Ethernet A interface for router 2, Ethernet A interface for router 1. Router 3 also has an Ethernet A, so don't be thrown off by that. Each router only knows about its own interfaces. So if you're trying to send to network 3.0, you send a just say we send a packet from here. Router gets it, and it says, okay, destination IP address is in network 3.0. I'll send it out on WAN A. This gets to router 2. Router 2 says, oh, IP address 3.0. That should be sent out on Ethernet A, and that packet will be sent out here in a frame, and it should reach its destination. So we're ignoring some of the things. How does it know how to get it to the right computer? That all happens with something like a ARP table, ARP cache. Okay, so let's take another example. Router computer in network 1.0 wants to send them something to network 5.0, a computer here. So it'll send a packet inside a frame through to Ethernet A, and then router 1 reads it, notices that the packet has a destination IP address of 5.0, says, I'm going to send it out on the interface WAN A. So it sends it out here. So routers just know that it's going to take something in, send it out on one of the ports. It doesn't know how it's going to make it to its destination. It's the other routers and the other routing tables set up all so semi-independently that figure out overall how the message reaches its destination, how the packet reaches its final destination. Okay, so once again, you're sending something to 5.0. This goes up to the routers. The router says, okay, send it out on WAN A. Reaches router 2, and it says, okay, you have a frame with a packet inside with the destination IP address of 5.0. This should go out on WAN B. And you can see it's heading in the right direction. You send it out on WAN B. This comes in on WAN A, and it says 5.0. Well, that should go out on Ethernet A. That's actually the only possibility. And so it sends out that packet inside a frame that router 3 constructs, and it sends it on to its final destination. Okay. So routers, once again, they work with IP addresses and routing tables to figure out which interface to send out a thing on. So every computer, and you've probably done this, you probably did this in lab number 3, that is, you have to figure out, each computer has to know if some if some packet is destined for a computer outside your local area network, you should know what the default gateway is. And so you always configure the default gateway unless it's done for you automatically. So default gateway is pretty much one of the interfaces of a router that's on your network. You can have multiple routers, and so you have to choose one of them. Typically, however, a local area network will just have one router interface, but you can have more than one. And you will have to configure each system or station on this LAN to have a default gateway, which is where you will send packets and frames which are destined for outside your local area network. Each router will have routing tables, a routing table, and inside a table, if you don't know what you're connected to, you will say, for example, 5.0, you're not connected to 5.0 in router 1, right? But it says there's an entry for 5.0, just send it out on WAN A. Basic idea is that this router just trusts the other routers to do the right thing and send packets that's destined for 5.0 on its way to eventually make it to network 5.0. So all of these routers, their routing tables have to be sort of, although they're independent, they have to be, there's some coordination so that anytime you want to send to a computer that's on a network that's not directly connected to you, you have to trust that the other routers are set up properly to get all the traffic to their final destinations. So there's always usually a default route. If it's not something that you're connected to, then you say, okay, send it out on the default interface. Okay, and if you ever try to find a network, like you ping something that doesn't exist, the router will try its best to send it on its way, but then if no other router can find that destination, you get a message back and it'll say something like network unreachable. That's the kind of message that you will see. Okay.